right. Cool. We're back. Hey, everyone. Thanks for joining. We're back in the basement. I'm Michael Walter. We're building stuff on AWS. Had a great time last week. So thanks to all that joined and all of those who took a little time to watch it after the fact. It was lots of fun. And I feel like we kind of got started on something. So this week, we're going to build on what we did last week a little bit. And we're going to build an actual project, something I've been thinking about working on for a little while. So hopefully it'll be fun. We'll get to try out some different AWS services along the way and learn a little bit more Go, that kind of stuff. So thanks for joining in or tuning in. And I'm on a new platform today with StreamYard instead of OBS. So this seems a little bit better, a little simpler. So hopefully it'll work out, um, and we won't have too many technical difficulties. But we'll see. So let me switch screens over to here. Got my desktop going, and oh, you know what? I can do this. Let me switch back real quick. Let me do it a little bit differently this time. Uh, Hang on. Oh, yeah, I have to do it this way. Okay. Do. We'll do just this window. No, just this window. Yeah, there we go. And I'll go down here. So now you can see it a little bit more clearly, I hope, back in VS Code. So I've got open here the project we were working on last week. And so just to do like a quick recap, what we did last week was basically a hello world kind of thing. And we spent quite a lot of time doing a hello world, and that's okay. And the idea was to learn a bit about just writing a hello world program in Go, compiling it and running it, and then to deploy it on Lambda. And so we wound up doing that. And then we even took a look at AWS SAM, or the serverless application model. And we were able to deploy it that way too. So right from the command line, sending up our Lambda to AWS, and then taking a look in the console and running it from there and that kind of stuff. So it was pretty simple. We spent a lot of time just looking at the basics of how that works. So I wanted to kind of pick up where we left off a little bit and talk about how you can actually run your Lambda. So last time, if you recall, we had to go into the AWS console and do like a test event there, and that worked. We got a hello world statement printed out to the logs, all good. But in the real world, that's not a kind of typical scenario. So something actually has to invoke your Lambda function for you. And there's lots of ways to invoke a Lambda function on AWS, but to invoke one from like a public endpoint, so through an API call, that sort of thing, there's really only a few ways to do that. And one of those is API gateway. So we're going to take a look today at API gateway, how to add that to your project, and kind of what it can do. So here we are in our VS Code project again. I'm going to jump over to our SAM template. And so if you could recall from last time, the SAM template was super simple. We just had this one serverless function here, defining our Lambda, pointing to our Go code. And then down at the bottom, there's this log group definition just to create a log group for our function. So it's very straightforward. Really just two things. And in fact, if we go into Application Composer, where we can see kind of a visual version of all this, let me make it a little bit easier to see here. Yeah, it's just this one Lambda function. So on its own, it's fine. You can test it out in the console. You can invoke it right here from the command line, and you can invoke it locally on your own machine to do testing and development. But in order to invoke it remotely from an API endpoint, we need to add an API gateway. And so that's really simple. I'll just move this over a little bit. we add this guy here, API gateway, to our application composer canvas thing. And you'll see it gives us some basics right out of the box. So we have an API gateway, we have our Lambda function, and you get a get method. Um, defaults to having a get method there for you. So if you click on this and you go to details, you can fill in some more information about it. So we can give it a name that's something better than API. We can call it Hello Lambda API. That's a little bit better. You can add authorizers. We're going to keep this a public endpoint for now just to make things simpler. But if you want, if you need to have authentication on your API, you can add that. There's a couple ways to do that. And then in here, you can add different routes. So we have, by default, we have a get method with the root path. But if we need more, we can add more routes. So we can add, other paths for different resources. We can add or select from all these different types of methods, depending on what we're trying to do. You can kind of design it any way you want. And so what we're going to do now is we're going to just use the get method and this root path. There's a bunch of other details you can fill in having to do with cores. And then we can click save. And what we've done is we've created our Hello Lambda API gateway. But what we need to do now is associate this route with this Lambda function. And it's really easy to do. You just draw a line right to it. It says connection has been made between Hello Lambda API and Hello Go function. And so now we can go and look at our template code here, our SAM template. And we can see down here, it's added this API resource right here. And so that's our new API gateway that we've added. And it's got a bunch of properties that we just defined in the template. All the core stuff is here. If you put that stuff in, it has the one path we selected. And then if you look up at our Lambda function now, here's our Lambda function definition, you'll also see that there's this area called events. And so now that Lambda function is associated with this API that we just created, the Hello Lambda API get method. And it tells it what to do. So it tells it it's going to use the root path. It's going to be a get method. This refers to the Hello Lambda API we created. So it's all wired up. Cool. So what does that mean? What can we do now? So let's just give it a shot. So we have our Go function here. It just prints out this hello Twitch message. So let's take a look on the command line and see what we can do. So you can actually run an API right here on the command line. So we can do, let's do SAM build, just to build our new thing. So that's going to add the API gateway. And instead of doing a regular SAM local invoke, because that will just invoke the function, let's try that just to make sure it still works. It's been a week. So we do SAM local invoke. We should get back our hello Twitch here in a second. Let's see if it works. All right, it's building it. Cool, there it goes, hello Twitch. So it ran right here in the locally on our terminal. But you can also do SAM local start API. That will do is it'll create a local running API on your system. So it's giving you a URL. So let me just copy that. And I'm going to make a new terminal. So we can do this all in the terminal. And let's just do a curl of that API and see what happens. Cool. Well, we got a message back, but it says internal server error. And there's a reason for that. So take a look at our, so it kind of worked, just to clear it up. So if we look back here, we got a invalid Lambda response received. So Lambda returned a string instead of a dictionary. So it didn't like what we were sending it. So API Gateway basically had uh, a problem with what we just did. So if we take a look at our code, all we're really doing is we're returning a string, and API Gateway wants this dictionary. So what we need to do is we actually have to modify our Lambda handler to be able to handle a request from API Gateway, because that's what we're integrating with. So to do that, it's very simple. Let me just grab my notes here so we can do it quickly. One sec. That's the wrong one. Here it is. Okay, so to do that, all we really need to do is add another package to our Go project, which looks very similar to this one we're looking at here right now, except it's instead of Lambda, it's going to say events. So let's do a Go get, there it is, AWS Lambda Go / events. And then we're going to add that here. We need to put it in quotes. And it's telling us it's imported but not used. Yeah, we haven't used it yet. So it's just giving us a warning that we haven't actually used it yet. So what we need to do to use it is to add it to our function handler. And there's a couple places that we can do that. First of all, we can add a request parameter. So in here we can type request, and we can say events.api gateway proxy request. That's the kind we want. Let's see, API gateway proxy request. There it is. So this is a parameter called request that's going to come in, and it's going to bring in the body of the request that we're sending to API gateway basically into the handler. But we also want to change this return from a string, because a string is not what API gateway wants back. We're going to turn this into, also from the events package, API gateway proxy response. And that's what we're going to use as a return statement back to API gateway. So we're not quite done. We still need to modify what we're returning. We're still returning this string, hello Twitch, and we actually have to return an API gateway proxy response. And if you look at the help here for that, it says we are going to return a number of fields here. So there's the status code, which is an integer. We can return headers, multi-value headers, a body as a string, and whether or not it's base64 encoded. And I'll talk a little bit in a little while. I'll talk a little bit about what this struct stuff is in Go. But for now, just sort of think of it as, this is the structure. This is the fields that we want to return. They're not all required. We at least have to return a status code and a body. So to do that, again, super simple. Instead of returning the message, let's just comment this out for a moment. We're going to return events.api gateway proxy response. And then we're going to open up this curly braces and put in the two fields. So we want to put in our status code. We're going to send it a 200 since it's a success. And then we want to send a body. And our body is going to be our statement, so our string message. I think we have to put let's see, is that enough? Not enough return values. I forget. Oh, of course. So I returned the API gateway proxy response, but I also have to return an error if we have one. We don't have an error. We're going to return nil. So that should be okay now. All right, so let's see what happens if we try to run this now. So we're going to first do a SAM build. Okay, so we did SAM build. I think we need to quit our API and start it again. Okay, and now let's switch terminals and let's see if we can do that curl command again and see what we get. So we'd go curl, and there we go. We get a hello Twitch back as the response, nice and clean uh, response body there. So that's good. Let's go back to this terminal here and cancel that for a moment. So we built this project now and we want to deploy it. So let's do a SAM deploy. I'll make this a little bigger while it's doing that. And so we changed our Lambda function, but we also added an API gateway. So it's going to go through and rebuild our artifacts and then upload them to AWS. And then we should be able to actually run this. Uh, that looks kind of crazy. Hold on a second. There we go. So it's going to add some permissions to allow API gateway to talk to our Lambda function. And it's going to modify our function and add an API gateway. So yes, we want to do that. Let's do that. So we're going to give it a minute. It's going to start updating through CloudFormation. While that's working, I'm going to bring up the console. Hang on one sec. Okay. All right, it's been deployed. So let's hold on one second. Let me sign into the console. And I just realized you can't see this, so let me just change the screen a little bit. One sec. All right, console. All right, there we go. Let's make this a little bit nicer for everybody. Okay, so now we've deployed our Lambda function updated to work with API Gateway, and we've also created the API Gateway. So let's go take a look first at the Lambda function and just sort of see what's different, what's changed. So here it is at the top, deployed a minute ago. If I go into that Lambda function now, uh, we can see an API Gateway is now set up as a trigger. So Lambda functions, like I mentioned, need to be triggered by some kind of event. You can trigger them by all sorts of things internal on AWS, but to have a public endpoint of any kind, you have to use something like an API gateway. There's a few other ways to do that, but API gateway is probably the simplest one. So we've got it all wired up here. You can sort of see it visually acting as a trigger. And so now if we go over to API gateway, we can actually see how it works. So there is our API, Hello Lambda API. It tells you which stack it's from. And we can go into here and you can see different information about the API. So here we can see the get resource we created, and it gives you kind of a visual in terms of like what's happening. So a client makes a request to the API get resource here. That fires off an integration request to our Lambda. That's that proxy request thing we saw in the code. And then Lambda does its thing and returns a response. So we get an integration response back from Lambda, and that returns back to the client. That's pretty much it. So let's see, somewhere in here there should be the URL. Let me just see here. One second. Oh yeah, okay. So keep this sidebar opened here. So this sort of shows you the definition of everything and under resources. And then there's these stages, and stages are, you can have different deployment stages. So you can have a production stage and a staging stage, or any other stages you want to define. So here's the actual URL it created for us right here. So I can copy that, and we can actually do this right in the browser since it's just a get method. We can paste this into the browser, and there we go. We get hello Twitch. And so that's our production API endpoint we just built. So it's all wired up. That means we can go back to Lambda, go to our function, and take a look at what's happening under monitor. Let's just change this to 1 day. So you'll start to see those invocations. There was a couple invocations we had, I think, earlier when we were testing it from the command line. And then eventually here, we're going to start, there's one invocation. We're going to start to see anytime we hit this API over and over again, it's going to run our Lambda function. And it takes a couple seconds, but eventually it'll start to show up here as an invocation or an error if we have an error, that kind of stuff. So all good. So that kind of brings us up to speed. We've created a hello world Lambda function. We deployed it with SAM. And then we just added just now an API gateway to create a public endpoint that allows us to call that function. So that's cool. Okay. Let's see if it's going to do it. I just want to see if we get some more invocations here. Oh, you know what we can do? We can also take a look at the logs. So we'll still have our log group, the same log group as before. And we can, we can take a look at our CloudWatch logs here. So there's a new log stream. And that was just from a couple minutes ago. So that's the one we just did. So there's a bunch of hello Twitch logs jumping out here. Very nice. Cool. And yeah, you can open each one up or the report and see things like how much time it took, 2 milliseconds. That was how much we were billed for. It actually took 1.56 milliseconds to run our hello world code. Not a whole lot. So that's nice. All right, so let's move on a little bit because what I want to do is talk about what project we're going to do today. Because it's not just going to be hello world anymore. We're going to move on. We're going to build something kind of fun. And yeah, let's take a look. So years ago, I think back in like 2015 or so, maybe, I created this project at work where I used to work. I used to work in a museum, and I created this project called Curatorial Poetry. And so this is back before the days of generative AI, but we were at the museum really excited to launch an open API for the museum. So the entire collection of objects in the museum's collection were accessible through an open API, and they still are. And so to kind of kick the tires with the API, I built a program using Python that basically grabbed a field from our collections API, just a single field that sort of describes each object in that collection, and then creates a Tumblr post. Back then, Tumblr was the thing to post to. So this is just like a archive of all of those. So they're kind of fun because without any context, without any information about what you're looking at, they're sort of like these little poems, right? So a book of drawings of baby frocks of the period 1920 to 1940 with details of needlework, samples of the same and patterns. Very nice. Some of them are kind of lame, reproduction, but some of them are pretty interesting, and they're just sort of these visual descriptions of what the objects are in that collection. So it was a fun project, and I thought maybe for today we could kind of like revisit this old project and build it a little bit differently now that we have tools like generative AI. Maybe we can use another museum's open API to create some poems generated but inspired by art objects. So whenever I do a project like this, or if I come up with an idea like this, usually my first stop is to think about kind of prototyping the idea a little bit. So let's do that. So the first thing I want to do is kind of in my mind sort of draw together a diagram, or we can use this tool here to sort of sketch it out of what we're going to actually build. Right, so I use this program called Draw.io for a lot of things. It's a nice way to sketch architectures. It's got all the AWS icons built into it. So it's really easy to use. Let's start with like a browser. So here's like a nice browser icon. And yeah, we're going to make an AP, another similar architecture to what we just built, right? So we'll have like a API gateway. Here it is. So we just learned that's kind of like our public endpoint into our Lambda function. So we have this API gateway. Here's our browser making an API call. So it's going to make a request to the API gateway. And then we're going to have our Lambda function. It's going to do all the work. So let's see if we can find, I like these square ones better for some reason. All right, there's our Lambda. It's going to be written in Go. And our Lambda is going to do all the work. It's going to take this request. It's going to get an artwork from an open API. So for that, we're just going to use a little box. All right. So let's call this art API. I'll get into where that lives in a moment. So it's gonna, let's see. So our API gateway is gonna say, "Hey Lambda, do some stuff for me." Our Lambda is going to go and fetch a artwork from this API. Let's clean that up again a little bit. The API is going to return that artwork to our Lambda function. And then our Lambda function is going to take that artwork. It's going to be like a JSON object. And we're going to use a new service, a newish service called Bedrock. Let's see if it's in here yet. Yeah, it is. Cool. So we're going to use this Amazon Bedrock, which is a generative AI service that allows you to access all sorts of different large language models and other kinds of foundational models from sort of like a unified interface. So we're going to take what we get from the Art API up here, and we're going to send it to Bedrock. Bedrock's going to generate a poem for us. We're going to have to do a little prompt engineering to tell it what we want. And then it's going to send that poem back to Lambda. And then so on and so forth. We're going to send the poem back to API through API gateway back to our client in the browser. So that's it. That's the architecture we're going to build today. We already sort of built this middle piece here last time to do our hello world. We're just basically going to add on a little bit more complexity to make it do some more interesting stuff. Okay, cool. So let's talk about this API here. So there's a museum called Cleveland Museum of Art that has a really nice open access API. And one of the nice things about it is it's very easy to use. They've got over 64,000 artworks in this collection, all accessible through this API. And this page basically tells us how the API works. And down here below, scroll down a little bit, it gives you some documentation about how to use it. So there's a search API, so you can search for different kinds of things. And then there's also, scroll down a little bit more, there's a method that lets you get a specific artwork. So you just basically put in an identifier for that artwork, and it'll give you back a whole bunch of JSON data, a whole bunch of fields. And if you take a look, there's all sorts of stuff in here. There's this sort of tombstone thing. It's sort of a museum speak for a description of the object, which tells you what it is and where it's from and some dimensions and that kind of stuff. There's a title field. This one happens to be head of St. John the Baptist. A bunch of date information, where it's from originally, the culture, its medium, so oil on canvas or technique. and so on and so forth. There's tons of information about every object. If you go down further, you'll see there's these long descriptions. So this one has a whole paragraph of information about this particular piece. There's citations for other resources you can look at, other related works. And every object has varying degrees of this stuff kind of filled out, depending on what the museum knows about each object. Uh, so this is the API we're going to play with today. All you do is create a request to this endpoint. You add the ID of the object that you want to use, and we'll talk a bit about that in a little while. And then it should return to you all this data. So here, this example, you can just click on it, and you can actually see it requested right in your browser, just like that. Pretty cool. Okay, so we know we can get this, right? We know we can get artworks back from this API, but I think what we'd like to do before we actually build anything is just kind of see what Bedrock can do with it, or what some of the large language models we have available to us can do. So let's go over to the AWS console and take a look at Bedrock. Okay, so you just go to Bedrock. Like I mentioned before, Bedrock is kind of like this interface to a collection of foundation models. It does a whole bunch of other stuff, but at its core, that's kind of what it's designed to do. It gives you a unified API or interface that allows you to work with different large language models, text to image models, that sort of stuff. If you've never used it before and you're new in AWS, there's one step you need to do, which is to go down to this model access button here. And that's where you turn on or request access to all the models that you want to work with. I've already done that in this account, but if you have a new account or you've never used Bedrock, you'll have to go in here and click Manage Model Access and select the ones you want to work with. And as you can see, there's a whole bunch. So there's different model providers. Right now, we've got AI 21 Labs. Amazon has their own models you can work with. Anthropic is here, Cohere, Meta, and Stability AI. And the one I really like working with a lot is this one from Anthropic. So we've got Anthropic's Claude model enabled. So you have to make sure that you've got your models enabled that you want to use. You don't have to enable all of them, just the ones you want to work with, but I've got them all enabled here. And then we can actually kind of prototype our idea by jumping into one of this playground here. So we can go to the text playground, and we can pick the model we want to use. So I'm going to pick Anthropic. Let's use this one here, version 2. Click Apply. And the playground, you basically get this prompt area, right? So you can paste in a prompt. Let's just try a quick one. So how are you? And then you click Run. And you'll see it will spit out an answer. So I'm doing well, thanks for asking. All right, so you can type whatever prompt you want. You can say, what is GitHub? I just like to do that one. Click Run. And it'll start printing out the answer. GitHub is a code hosting platform for version control and collaboration, so on and so forth. It keeps going. Pretty cool. So it gives you a pretty nice synopsis of what GitHub is. But that's not what we're here to do right now. So what we want to do is try out our idea. So let's jump over to here. I'm going to grab this, or just by copying and pasting it. So I'm grabbing this whole JSON object here from the Cleveland Museum of Art API. Oops. And I'm going to paste it into our prompt here. And let's scroll back up to the top. So there's a whole bunch of data here. It's a big document. And what I'm going to do is I'm going to surround it with a tag, document tag like this. This just helps Claude know what I'm talking about. And yeah, you'll have to like sort of read up on the Claude documentation to understand some of this stuff, but that's how Claude likes to make reference to things. So now, so a slash document to end that space. And now I can say a prompt like write a short poem inspired by the document below. Okay, so I'm making reference to that document and asking it to basically write a little poem using this document as inspiration. So let's see what it does. All right, so it's going to say, here is a poem inspired by the artwork. And it's made us a poem. Look at that. Severed head of the Baptist, gazing with hallowed eyes, mute witness of sacrifice given for truth's behest. Interesting. So it's in kind of a particular style too. So you could probably change this a bit to add like write a short poem in limerick style or soliloquy or something like that, and you would get a different result. But this, this whole process here is just to kind of prove that what we want to build might actually work. So it looks like it's going to work. Um, Hopefully that will be good. And we can leave this open for later so we can go and test other ideas and see how it goes. But that's just a quick way to try something out. You'll notice in Bedrock there's a bunch of other parameters over here on the right. So you can change the temperature, the top P or top K. These are sort of levers you can pull one way or another in your prompt to tell Claude kind of what you want to do. So they have to do with like how many words they're using to sort of generate the next word in the response, that kind of stuff. You can give it a limit in terms of how long you want the output to be. So this one's set to 300, so we can make that longer if we need like a really long poem or something like that. And so each model is going to have slightly different um, uh, configuration options over here on the right. But this is Claude. Claude is very, very easy to use and lots of fun, very powerful stuff. Okay, cool. So I think our idea works. If we look at our diagram, we make a request to API Gateway. That calls our Lambda. And then it's going to, what we want to do is we want to fetch an artwork from the open access collection at Cleveland Museum of Art, and then use that, whatever it returns, to send a request to Bedrock, where we're going to get a poem generated for us, and then send that poem back to the client. That's the idea. All right, so let's get started. So let me jump out of, hang on one second. Let's go back to VS Code. Where are you, VS Code? Here you are. All right. So let's start with a new project in VS Code. Open folder. You can't see this part, but I'm going to type in go generate poems. How's that? Okay, so we're going to start a brand new project in VS Code. Awesome. All right, so let's close our welcome screen. And the first thing we always do for a new project in Go, again, is we do the go mod init. So we're going to do go mod init, and let's call it go generate poems. All right, so it creates our module. There it is. That's where all of our dependencies are going to land again and be tracked. Okay, so to kind of get started, what we need to do is create just sort of create basically the hello world example again. So let's just make a main.go file. We're going to call it package main. Let's import foomt to get started. If you remember that from last time, foomt is the package that lets you do things like print and is short for format, and it lets you format strings and print them to wherever you want to print them to. And then we need to do a function main. Doesn't return anything. And before we get into the Lambda stuff, like oftentimes I like to just build right here in the main function just to kind of get things started. So let's do that here, and we'll just do things from the command line locally on our system before we go and make it into a Lambda function. And there's sort of like two schools of thought on that. So it might be more efficient to actually build the Lambda and use SAM local invoke to do our local testing. But to me, it kind of makes more sense to do it this way. For a program that's this simple, we'll just build it right here in the main function. And then once we are kind of happy with how it's working, we'll go through the process of turning it into a Lambda function again. Okay, so sounds good. So let's just type some stuff here just to kind of get things started. So we're going to do another hello program just to kind of like make sure we have all the right pieces in the right places. So let's do a go run main. Make sure we're up and running. There we go. Hello, it worked. Cool. And so the way I usually do these things is I sort of sketch out what I want to do in comments, and then I start kind of building the code from there. So the first thing this function is going to have to do is fetch an artwork. Fetch an artwork from Cleveland Museum of Art Open API. Then it's going to have to take that artwork and craft a prompt with it, I guess is a good way to say it. So let's call that craft a prompt with the artwork. And then we're going to send that prompt, send prompt to Amazon Bedrock to get a poem. And then we want to return the poem. That's basically it. That's what we're going to make this thing do. Cool. So how do we do that? So first thing to do, let's just start from the top where we want to fetch an artwork from Cleveland Museum of Art Open API. So let me just grab a note here. This is actually pretty simple. So in Go, there's a lot of built-in packages. We talked about the foomt package last time. There is also a HTTP package. It's actually part of the net package. I'll show you that in a second. And so let me just type it. Okay, so we're going to get a response back. We're going to get an error back potentially. And then we are going to do an HTTP.get because we're doing a get method. And we have to send it a URL. So that's the structure of a get method from this HTTP package. If I hit save, it's going to automatically add the package up here to my import list. So here's the net/HTTP package. You can go and look at the documentation for this on the package website, or just hover over it here in VS Code, and you'll see what it wants. So it wants a URL to fetch. Simple as that. Cool. So what's our URL? So first of all, let's add a constant. So there are constants in Go. We're going to call this endpoint. And I'm going to paste in from my notes over here what the endpoint is so you can see it. And there it is. That's sort of the base endpoint from the Cleveland Museum of Art's Open API. So it's just this long URL /API. If we just did that, if we used our endpoint, it's not going to give us anything because we're not telling it what we actually want. So in our get call here, we have to sort of format a URL. And so the way to do that is to use the foomt package and sprint f. And what this will let us do is create a string from a bunch of components, basically. So it's going to be for endpoint. And then we're going to add this artworks and %v. I'm going to put a comma, and let's put in an ID because we need an artwork ID. Okay, so that's a little bit better. Let me make this a little bit easier to read. There we go. Okay, so we have this sort of base endpoint here. And then in our get function call, we're going to create this URL. So we're going to start with the endpoint. We're going to add artworks, which is the resource that we want to call. And then we're adding this %v here. And this basically says whatever's over here, turn it into a string. So we're going to have a number for an ID. So I copied this off their website as well. ID equals, let's use the one that they were using as an example that we just looked at. Okay, so here's the ID. Okay, so a couple of things here. There's a couple of different like data types going on. First of all, we have a constant string. And so when you do a constant, it's basically a string literal. Like whatever you put in here is the data type. So there's no, it's not actually a string data type in Go. It's just a literal. And then this syntax here, you might have seen me do a couple times now. So this is kind of like a shortcut in Go to create a variable. So in this case, we have, whoops, sorry. In this case, we have ID : equals and then a number. And what Go is going to do is it's going to figure out what type this is. So it's going to infer that we want it. This is an integer because there's no decimal point and there's no quotation marks or anything like that. And it's going to create a variable called ID that's of type integer. And if you hover over it, you'll see it'll say var ID int. And so, like I said, it's a shortcut. You can actually, instead of writing it that way, you can write it just like it told you, var ID int. You can sort of like declare it like that as an integer. And then you can set it equal to a number right there. Or you can set it equal to a number somewhere else. There's a number of ways to sort of do this. This is the most expressive way to do it, I would say. But this is the shortcut. It's probably the most common way to do it. So we're going to do it that way. And then you can see here it's used again. The shortcut is used again here to create these two objects over here, a response object and an error object. And so it's going to say, what does this thing return to me? A get function from the HTTP package. And you can see it returns to me an HTTP response object and an error object right here. So it's going to set these two variables to those types automatically for us. And then in here, what we did was we used the sprintf function to format what you see in here into a long string, basically. Okay, but you can see there's a couple warnings here because we haven't actually done anything with this response. So Go will give you a warning, or actually an error, a compiler error, if you create a variable and then you don't use it in your code. And that's just exactly what we've done. We've created a response variable and an error variable, but we're not doing anything with that. So that's not going to work. So what I really like about Go is that it kind of encourages you through these compiler errors to think about things like error handling. So a really common practice is that right after you write a statement like this, you handle the error or potential error. So you can just say, if error does not equal nil, what am I going to do? I'm going to, this will be kind of fun. I'm going to log an error, a fatal error. So I'm going to log fatal. We'll do fatal F so we can get some formatting in here. And I'm going to say error, percent %v again, and I'm going to dump out the error. So what this is going to do is if we get an error back from this get request, so let's say we get to this part in the function, and for some reason we don't get a response from Cleveland Museum of Art. What it's going to do is it's going to notice that there's an error, so the error is not nil, and it's going to use the log package to log a fatal error. And what a fatal error does is it actually does two things. It will send this error message to the logs, but it will also crash the program. It'll send a panic message to the program. So if this happens, it's over. It's just going to crash the program for us, and that's kind of okay. All right. So, but you can still see that the response is not being used. So we're not done yet. We haven't actually done anything with the response. Okay, so we have to do a couple things here because this isn't quite enough. This will just tell us if we get like a if we can't satisfy the get function basically. But there's a scenario where we get a error back from that get request that's seen as a success to this call. So we can get like a 404 back, or we can get a 500 error back from the get request. And that's not really uh, an error of the get request. It's an error of what we're trying to get, basically, if that makes sense. So what we want to do is a couple of additional error handlers, right? So we want to try if response dot status code does not equal 200. So anything besides 200, we're going to log another error. Log fatal F. And this time, our error is going to say, let's say, could not fetch data. And we'll put that %v. Actually, we don't need, we want to put the %s here because we're going to be taking a string. So response dot status. All right, so that will give us, well, what did it do? So we didn't get a 200 back. What did we get? Did we get a 404 or did we get a 500 message? Well, what was the response? So we'll log that as well. But there's one other command we have to do here that's kind of interesting before we can start playing with the response. We have to close the fetch, the get request. So we do this thing called defer. Response body dot close. And defer is an interesting statement. What that does is it says we want to do this statement, but we don't want to do it until function main is done doing its thing. So it's deferring that statement until everything else is done in the surrounding function, basically. And all it does is basically close the response body thing there. Cool. So we've handled the case where we might get a 200 error back. That's probably pretty good. Or a case where we don't get a 200 back. What else do we need to do? So now we actually have to deal with what we do get back. So let's say we get a 200 back. Now we have a bunch of data to play with. So how do we actually use that data from the response? So we saw that there's something called a response body. What type is a response body? It's an IO dot read closer. So to actually read that into something useful, what we can do, let's just use a different variable name like b. And again, we'll add an error in our little shortcut, and we'll do an IO read all. And we're going to read the response body. Right? And so what we're basically doing here is we're using the IO package to read whatever is in the response body and save it into B. the variable called b. If you look at this function, let's see. Oh, we probably have to save it first. Okay, so if you look at this function, you'll see it's going to send us back a byte array and an error if we have an error. So first, let's handle the error, just like we did up here. So if we have an error not equal to nil, what are we going to do? Let's log another fatal. Log fatal f. This time we're going to say could not read response. And we'll do that %v again, comma error, just to print out whatever the error might be. Cool. So now we've got we're handling the case where we can't read from the response body, and now we've got a byte array. Okay. So at this point, what we might want to do is just sort of test what we've done so far, but we can't yet because we have to do something with this b variable. So what we can do to sort of give it a sanity check, we can print it out. Let's do print line, but we can't just put b. We have to first change it to a string. So let me just show you what I did there. So I want to do a print line statement function of whatever's in b, but b is a byte array. And so what I have to do first, print line is going to expect a string, is I have to convert that byte array to a string, and I can do that just by putting parentheses around it and typing string. So we're casting that byte array to a string. So it's very simple to do. So let's give it a shot. Let's see if this runs. Let's make this a little bigger so we can see it. Okay, cool. It printed out a whole bunch of stuff. That's awesome. All right, so this is our JSON. There it is. There's all the JSON stuff printed out already. Cool. Okay, and we're still printing our little hello statement at the end. So it worked. That's awesome. Okay, so now we have to turn this into something useful that we can send to Bedrock. Okay, so the first thing we have to do is kind of craft a prompt. So a prompt, remember when we were in the playground area, we pasted in a bunch of stuff and we typed a little prompt that said, generate us an artwork. That's the prompt. That whole entire thing is the prompt. So we have to create that in code. So to do that, what we're going to do is talk to Bedrock. And so to talk to Bedrock, what we have to do first is add the Bedrock SDK. So let me just do that real quick. Copy them from my notes again. All right, so we're going to do a go get this thing called config. I'll explain that in a moment. And then we're going to get an API called Bedrock Runtime. So Amazon Bedrock has several different APIs. Bedrock Runtime is the one that lets you actually, whoops, forgot the go get part. Bedrock Runtime is the one that actually lets you invoke the models. So let's do go get Bedrock Runtime. And there we have it. So now we can add those to our import, although we don't really have to. They'll automatically come in here, but let's do it anyways. So there's those two SDKs. And so this AWS SDK Go version 2 is basically a package in Go that lets you interact with pretty much everything under the sun at AWS. So all the different services that are available, including Bedrock, you can work with in Go using this SDK. So we're going to just import the Bedrock runtime part of that SDK. And this one called config. And the config one, all this really does is it sets up your credentials for communicating with US. All right, so we'll get to the prompt part. We're going to come back to this prompt part in a minute. Let's actually create the config bit here, because this is a little bit, it could be a little bit confusing. Okay, so we're going to create a config here. CFG we'll call it, and it also returns an error, like usual. And so we're going to type config dot load, there it is, load default config. Okay, so that's sort of typical function that you'll call to create a configuration. And so what we're going to put in for parameters, there's a parameter called context. I'll explain this in a moment. And then there's a second parameter where we want to put in the region that we're working with. Now, you don't have to do this. This is optional. You can use whatever default region you're set up on, but I like to specify the actual region we're working with, US East -1. So there's no confusion. Okay, so that statement is going to tell us to load our default configuration. Um, it needs this context parameter, and the to-do basically sends an empty context, essentially. So we're not actually using this, but we need to put it in here as like a placeholder. And then we're configuring it with the region US East 1. And so all this is doing is it's going to, in this scenario, it's going to take our credentials off our machine, off our local system, and use them to authenticate with AWS. In the world of Lambda, it's going to do the same thing, except it's not going to pull them off a local system. It's going to pull them from the permissions you have attached to your Lambda function, more or less. So we'll talk through how that works in a little bit. But first, like everything else, we need to handle the error. So if we are not nil, what are we going to do? Let's log a fatal error. And let's say unable to load AWS config, something like that. And this will just give us a little more insight into what might be going on. So now you can see this config variable is not being used. We actually have to do something with it. So what we're going to do is we're going to create a service variable using the Bedrock runtime SDK. And we're going to say new from config and put in the config variable. So we created a config here, and now we're using that config to set up a Bedrock runtime service. You can follow that. Okay. So there's a few things here we have to add to talk to Bedrock. There's a few kind of like required parameters. I'm just going to paste them in here like that. And these are parameters that you're going to send to Bedrock every time. So we're sending some accept headers, a content type of application JSON, and then the model ID that you want to work with. So like you saw in earlier in the console, there's lots of different models you can choose from. We're going to be working with Anthropic Claude version 2 for this demo here. But you can put it to whatever you want, depending on which model that you're working with. Okay. And so then the next bit is to create the call to Bedrock. And let's just do that. Let me hang on a second. Let's see here. Okay, this is where it gets a little interesting. So in Go, we have these things called structs. So Go is a statically typed language. Let me just save this. Whoops. So Go is what's known as a statically typed language, and that means that everything has to have a type associated with it. You can't have a variable that's untyped. There are some exceptions to that in Go, which are sort of interesting to look at. But in this scenario where we're trying to send a bunch of parameters to Bedrock, we have to use a struct basically to put them into the format that we want. So what we need to do first before we can actually do this next bit is create a struct. So we go up here, let's go up here to uh, sort of the top part of the program here outside of the function main. And what we're going to do is create a struct called body. You can call it whatever you want. This is basically what we're going to send as a body to our Bedrock API. And then this next part, I'm just going to copy and paste just to save some time, and I'll explain why in a moment, because it would take me a while to type all this stuff. So let's just do this and take a look at what I just did. So we created two structs, actually. So there's a body struct, and then there's this thing called anthropic response body struct. And you can see that in the body struct, there's a bunch of parameters. There's the prompt, max tokens, temperature, top K, top P, stop sequences, and anthropic version. And if you remember back when we were in the playground, these were all those levers on the right-hand side of the console that you can set to different numbers. So when you create a request to Bedrock, you have to tell Bedrock what you want those numbers to be set to. And the prompt at the top is sort of the most important one. That's where we send it what we want Bedrock to do. And then the second struct here is when the response comes back, we'll get it in a very specific way. So each foundation model will have a slightly different response body. And so the struct is really just meant to give us some structure to the data coming back. So we're going to get something back called a completion and a stop reason that just tells us why it stopped generating text. And you can see next to each one of these parameters, there's the type that it is. So it's statically typed. We're telling Go what type to expect. And then over here to the right, we're defining basically what the JSON body is going to look like that we're expecting to see, or that we want to send in our API call. So even though we have kind of like a capital prompt over here, in JSON we actually have a lowercase prompt, or we're using underscores, so on and so forth. This is what we actually are sending over the wire to the API. Okay, so I know that's a little bit confusing. It's a little bit more of an advanced topic, but you use structs all the time in Go. So as we kind of progress, we'll see how they're used and how powerful they are. But to get back to what we're about to do with Bedrock here, okay, so we created that config, and we set up our service. We created a few required parameters, and now what we need to do is create our body that we want to send to Bedrock. So to do that, I'm going to do a couple things here. Okay, so first of all, I'm going to make a variable. Let's do that here, actually, in this craft a prompt area. So I'm going to make a variable called, actually, let's do this. Let's say document. And I'm going to add those tags. Remember, I did this in the console earlier. Document. Oh, that's the wrong. We need an opening tag for document. And I'm going to say string B. So I'm going to cast that this thing as a string again. So we don't need to print it out anymore. And then I'm going to add the closing document tag. And I'm going to add a couple carriage returns or new lines. All right. And then I'm going to make a prompt variable. And for Anthropic Claude, it's really specific about how the prompt is formatted. So I'm going to copy this over my notes here so you can see it. So you have to add this sort of beginning statement called human. This tells it this is us talking to Claude. And then we're going to add our document to the top. And then our actual prompt that we want to write. And this is very similar to what we wrote in the console earlier. So write a short poem inspired by the artwork, described by the document. And then you have to add this assistant bit right here. This just is part of the way you format the prompt for Claude. And that's it. That's our prompt has been crafted now. Okay, so now what we want to do is use that prompt and our service and all of our other variables here to create what we want to send to Bedrock. So again, I'm going to copy and paste some stuff here so I don't have to waste time typing. Okay, so here we're using that. Oh, we have to make that. So we're basically declaring a variable called body, and we're using the struct that we created called body to define what it's going to be made up of. And then we're going to set all of the different um, uh, fields within the body struct to what we want them to be. So prompt is going to be equal to that prompt we created up here, this one. Max tokens, we're going to start at 300. Temperature is 1. Top K 250. Top P 0.999. That's a float type. These are integer types. We have our stop sequences, and you can get most of this stuff as a sort of starting point right out of the Bedrock console. They'll give you sort of a example API call you can do. I just sort of pasted it in here to save some time. But that's what's going to happen. We're going to use these as sort of starting numbers for what we're trying to do. Okay, cool. So now all we need to do is call Bedrock. And so, well, before we do that, this is an interesting thing we need to do. So the Bedrock is going to expect all of this stuff here, the prompt and all these variables, as a long JSON string. So what we have to do is convert the structure, this struct, into a JSON string. So in other languages like Python or Node, you'll probably be familiar with like JSON loads or JSON dumps. It's called serialization. So taking um, uh, a data structure like this and converting it into a serialized JSON string, basically. In Go, it's called marshalling and unmarshalling. So that's what we need to do. We need to marshal this struct into a JSON variable or a string. So to do that, we're just going to make a new variable called body string. We're going to put an error in there, and we're going to say JSON.marshal, and we want to marshal our body. Okay, so there's a JSON package built into Go. There it goes, and it takes one variable, which is the what you're trying to marshal, and it's going to store it as a string, or actually, it's actually a byte array, but you get the idea. Okay, so let's check our error. If error not equal to nil, we're going to do a log. Sorry, not. We're going to do a log fatal f. Unable to marshal body, I guess. And we're going to log the error. But now we have this byte array, which is made up of all this structure up here, this data structure. So now we can actually call Bedrock. And I'm going to copy and paste this as well, and then I'll just talk you through what I'm doing. So we're going to create a Bedrock response variable and an error. We're going to use that service, Bedrock service client that we created, and use the invoke model function. We're going to pass it an empty context for now, and we're going to pass it a Bedrock runtime invoke model input parameter. And that's what this looks like. So we have to send it an accept. So we have that variable already called accept, model ID, content type, and here's our body that we just marshaled, the body string. And so if we send this whole thing to Bedrock, we should get back a Bedrock response. And I have an error handler here. So if we get an error from Bedrock, like maybe we're out of tokens or whatever the case may be, we'll get an error message here. And then finally, what are we going to do next? We are going to deal with the response. So the response is going to come back as a Bedrock runtime invoke model output type. Okay, cool. So we can't just print that to the screen or return that. We need to actually turn that into a string. So what we're going to do is we're actually going to have to unmarshal that response back into a JSON string. So first of all, we're going to make a variable called out, and it's going to use that anthropic response body struct that we defined up here at the top. And you'll see there's a completion string and a stop reason string that comes back. Okay, so we're just going to declare that as this variable here. And then what we're going to do is we're going to unmarshal. And what we're going to send to the unmarshal is our Bedrock response.body. And this is a little funny how this works. We're using a pointer to reference this structure we just created. So that's going to update this variable by reference rather than by value. And that's just how that's set up to work. So we have to check our error. Do that. So if we got an error trying to unmarshal this, let's log it. And let's say unable to unmarshal response from Bedrock. But now we should be able to do something with our out variable. So let's try printing it. Print.println out.completion. Okay, so that should print out. We can get rid of this now. That should print out whatever comes back from Bedrock. Okay, so we did a whole bunch of stuff. Let's see if it works now. So we already tested the fetching the artwork part. We're going to fetch this particular artwork. But we haven't really tested crafting the document or connecting to AWS or sending all this stuff to Bedrock. So let's see what happens. Hopefully it'll work. All right, so let's run it. So it's taking a little while, and that's kind of a good sign because it takes a little while to generate a poem. And there it is. So we sent that document and our prompt to Bedrock, and it replied with this poem: serene waters still and clear, reflecting mountains far and near. Songzoo captured nature's grace, this quiet beauty, this peaceful place, rolling hills and misty skies, so on and so forth. A very nice poem. I wonder what happens if we run it again. Wait for a minute. We got a different one, slightly different. So we got a new poem: silken mists upon the lake, inked brush mountains in the distance. Songzoo captured nature's grace. So that's similar, but different, slightly different style using a few paragraphs. Cool. Okay, so it's working. We are grabbing data from the Cleveland Museum of Art Open API. That's what this does. We are checking for some errors. We're crafting a prompt based on what we got back from Cleveland, adding some, what we want it to do, write a short poem. We create a config for AWS and a service for Bedrock. And then we spent a lot of time just sort of getting all the data formatted the way we want to using JSON marshalling and structs. And then we sent this thing to Bedrock using the invoke model function, checked for an error, and we unmarshaled the response coming back into a string, and then we printed it to the screen. Cool, so that all works. That's kind of cool. I'm really happy with that. But it's not on AWS yet. It's not a Lambda function. And we have 10 minutes left before I have to go. So let's see if we can turn this into a Lambda function. So to do that, let's add, let's move some stuff around a little bit. Okay, so first of all, let's create a folder called source. You can call these whatever you want. I'm going to call this generate poem function. Let's move our file into there. Okay. Then let's make a new SAM template. Okay. Don't need that. And let's open it up with Application Composer. Give it a minute. All right, let's make this a little smaller so you can all see. So what do we need? We need an API gateway. We need a Lambda. We can close this and make it a little easier to look at. Oh, here's our Lambda. All right, so let's give the Lambda a name. Let's call it generate poem function. It's going to be a zip again. We're going to put it in the generate poem function folder. We're going to use provided AL 2023. We're going to use ARM64, just like last time. Our handler is Bootstrap. Everything else is the same. We can shorten this down. Let's do 256 this time. Give a little more memory. A 30-second timeout. I'll talk a little bit about why in a moment. Everything else I think is fine. So let's click Save. And then this API, let's give it a name at least. Let's call it Generate Poems API. And I think that's all we have to do. And then we have to wire this together. So let's just wire this together like that. Okay, and let's take a look at our template. And remember, there's always that one other thing we have to do. So we have to add metadata build method go 1.x, I think is what it is. That just tells it to build our function using the Go system the Go installed on our system. So there is everything. There's our API method. There is our log group. Yeah, it looks to all be there. Cool. But we have to do one more step before we can try this. So let's first of all, let's clean this up a little bit. So in our main.go, we're not returning anything. We're just printing it out. So as you might recall from when we first started, we actually have to return an API gateway proxy response. Okay, so instead of printing it to the screen, we can actually leave that print line here so that we can see this in the logs. That might be nice in the CloudWatch logs. But what we want to return is our actually, we don't need to do any of this. We can just do out.completion. And we'll hit save. And we're going to need to install our Lambda and our events packages. So hold on one sec. So let's say go get this, go get this, except we want events. Okay. And so now we can just say up here, there's our events, but we also need Lambda. Okay, and then this is all in the main function, and that's not really going to work. So we're going to change this to handler, and we're going to put in uh, our request events dot API gateway um, proxy request, and we're going to return events dot API gateway proxy response and an error. Oops. Let me make this a little smaller. Okay, so there now we have that correct, and then our return is now correct, but we still need a main function. So we need a main function. And as you might recall, all the main function does is lambda.start handler. Okay, so now I think we might have everything we need. So let's test it out. Let's do a SAM build. So now it's going to build our new function using Go, and it's going to, oh, it did it. Okay, great. So now we can do SAM local start API. All right. Okay. So it's running. It might have a cores issue, but we'll see that in a minute. Let's try this at a new terminal. And we're almost out of time, but we're going to make it here. We won't deploy this today, but we're going to see if it works, at least. It works. Look at that. Okay, so we curled um, our local testing API here, and we got back a poem, a different poem. Cool. Okay. What happens if we do it again? All right. Took a little bit longer, but we got back a poem, a little bit longer of a poem, and it works. So I'm going to skip deploying it to AWS today just because we'll wind up with the same result, and we can do this next time. But we did quite a bit today. We got through talking to Cleveland Museum of Art API. We talked about unmarshalling and marshalling JSON and Go. We talked about structs and communicating with the Amazon Bedrock API using Anthropic Claude as our large language model. And we talked about API Gateway. So we did quite a lot. Hopefully next time we'll be able to deploy this and try it out. And there's a bunch of considerations that we're going to need to talk about because, as you noticed, it took quite a while to get a response back, um, just because we're generating a a long poem. And so we might want to think about how we actually deal with that. So something to think about, how we can actually make the user experience a little bit better with some different strategies. But for now, it seems like it works. So that is it. Awesome. Let me jump out of here. And yeah, cool. Happy to say goodbye and have a great evening. Take care.